Back during lesson number 4, we learned about oscilloscope triggering and why it's important. Remember, triggering is essentially synchronized picture taking of the input signal so that the scope knows where to place captured waveforms on the scope's display. If you're using edge triggering, which is what you'll be using for most of your experiments, and it's also the only type of triggering we've talked about so far, the scope will position a rising or falling edge of the waveform, depending upon which slope you selected to trigger on, at center screen at the point where the signal edge passes through the trigger level. Let's now talk about auto versus normal trigger modes, which, to be honest with you, confuses a lot of veteran engineers, but it's important that you understand these triggering modes if you want to master the oscilloscope. Hi, I'm Johnny Hancock, Product Manager for Keysight Technologies Infinivision Oscilloscopes. Let's pick up where we left off in lesson number 4. So here's our 20 kilohertz sine wave that's the input to our resistive divider network. You've seen this before. Right now we're triggering right at center screen. As I move the trigger level up, you can see it shifting to the left until the trigger level gets above the waveform, and then it loses trigger. What's happening now is called auto triggering. The default trigger mode is auto, but that doesn't mean that it will generate an automatically good trigger. The scope has a computer inside. It's not synchronized to the signal that we want to trigger on. It doesn't know what the signal is because the trigger level is above the waveform. There's a timer running inside the scope that says, I don't see a trigger, I'm just going to generate a random or fake trigger. And it keeps generating these fake triggers over and over, and all we see is this blur because it's not synchronized to this. But at least we can see where the waveform is, and we know how to fix it, is move the trigger level down. Now watch what happens if I go to a very, very low frequency signal. I'm going to change the input to a 1 hertz signal. So 1 cycle per second. There you can see it moving up and down. Now remember, my trigger level, if I move it, you can see it's in the center, but it looked like it triggered there, but typically these points are going up in random locations. The problem is the scope's timer is running and says, I'm still not seeing a trigger. It won't wait a whole second. There's a way to fix this. Let's go into the trigger menu, and there you can see the default trigger mode, auto, which means generate an automatic fake trigger if there isn't a real one. If we change it to normal, now it will wait until it finds a real trigger. Even if the input signal is 0.001 hertz, it will wait that long before it will trigger. Now, if I move the trigger level up above the waveform, clear this screen, we're going to wait till eternity at this point. It won't trigger. Move it back down. Next time it happens, it triggers. And so the normal trigger mode, sometimes it's a little more difficult to set the scope up because you can't see where the waveform is. But if you have a very low frequency trigger event, you have to use the normal trigger mode. So now let's look at a special case of normal trigger mode. It's called single. So we're back to our 20 kilohertz sine wave. What I'm going to do is I'm going to disable the output from this function generator. And you see it goes to a flat line 0 volts. Now we're in the auto trigger mode, and if I'd have been in the normal trigger mode, it would have just frozen. But with the auto trigger mode, now it's auto triggering random triggers to at least show me that 0 volt line. What I want to capture is the startup activity of this function generator when I turn it back on. To do that, I have to use the single acquisition. I press single, it automatically goes into a normal trigger, but it's only going to trigger once when the startup activity happens. So I'm going to turn it on. There you see 0 volts, and all of a sudden it's trying to begin to generate 20 kilohertz sine waves, but it's kind of glitchy there. We could turn on the zoom mode, see that a little more clearly. We could do it again. We could turn it off, press single, turn it on, capture it again, and see how long does it take to start up and begin working normally. So this is a very typical application, not for turning on a generator, but startup activity is a very typical application for the single acquisition mode, which automatically goes into a normal trigger mode. Let's summarize what we've learned in this lesson. When should you use the auto trigger mode? When should you use the normal trigger mode? And when should you use single? Remember, the auto trigger mode is the scope's default mode, and that's what you'll be using for most of your experiments. If your input signal is highly repetitive, and if you have the scope's trigger level properly set to be within the peak-to-peak swing of your input signal, your scope will trigger or synchronize the display of waveforms. But if the scope's trigger level is not properly set, then at least with the auto trigger mode, the scope will show you a waveform that's untriggered. This will help you see where the waveform is relative to the trigger level so that you can then set the trigger level properly. But if your input signal has a very low repetition rate or low frequency, then you should use the normal trigger mode so that the scope doesn't generate automatic asynchronous triggers between real trigger events that are occurring infrequently. But if the scope fails to detect trigger events while using the normal trigger mode, the scope will display nothing, which can sometimes make it difficult to set things up. If you want to capture a single shot event, meaning that it happens just once, such as the startup condition of our function generator that we just demonstrated, then use single. In our next lesson, we'll be talking about trigger hold-off, which can be used to trigger on more complex signals that come in burst. See you in lesson number 12. Go, Colorado State Thunderwolves!